Hi, I'm working on my customer's Rittenhouse RCM4 master station. I guess this is like part 2 of that repair, or maybe it's 3, I forget. There's been a lot of work on this and we've made good progress, especially if we don't tip it over. One of the things that I talked about in the first section, or the first part of this repair video, was about on the back of the master station there are all of these sockets that the cabling from the remote speakers would plug into. The way this was done, apparently, the cables from Rittenhouse came pre-made in predetermined lengths, and the lengths of the cable, they have different colors of jacket on the outside of the cables denoting how long the cable actually is, and we'll get more into that as things go on. That's not exactly what this video is going to be about. These are all female, these are all sockets, but down here we have a male plug. And this plug is the connection that plugs into a socket like these that's mounted in the wall housing. When I was working on this set, I got to the point where I needed to actually power it up because I hadn't done that before I started, and I needed to work through what the connections on the plug end were to figure out where to apply power. So these are 6-pin connectors, and during the course of measuring out and measuring where the wires went from this plug and looking at pictures of what the socket and the wall housing looks like, one of the things I noticed was on the body of the little plug here, and I in the previous video talked about I didn't know what these were or where they came from or any of that kind of stuff, I actually got a clue. So when I was measuring the pins and looking at where the wires went and all those sort of things, I noticed that molded into the plastic body of the plug, and if I look really carefully I can see it again, it says Amphenol. And anybody who's worked on anything with electronics or electrical things knows Amphenol. They're a company that makes, oh, I don't know, they've been around forever and they probably make 1 million different kinds of sockets, plugs, connectors, all sorts of things. Much more high-tech than this. This is rather old school, but it gave me an important clue because it's a major name brand company that still exists. So I figured, well, they're the kind of old school company that they may still make something like this, or if nothing else, at least I can maybe figure out what it is, because there's bound to be a lot of documentation about it, because it's something that, you know, it's a big company. They're like the General Motors of connectors, and they probably made connectors for General Motors. I don't know. But anyway, at least it wasn't some obscure company. So it gave me a shot to try to figure out what these actually were. So I did some Google image searches, which is always a good way to find the right terms or pictures of what it is that you're looking for, because everything's on the internet nowadays. And I actually figured out more or less what these were. And then, of course, you go to the best source ever for stuff like this, because they don't apparently make these anymore. But you know that when they did make these, they probably made, oh, who knows, in the history of this plug, I'm going to guess they probably made 10 or 20 million of them. So, or maybe more. There's bound to be a lot of them floating around, a lot of new old stock ones and leftover ones and all that kind of stuff. So, of course, I went to eBay. And when I went to eBay, I put in Amphenol and just started looking at listings and pictures to see if I could come up with something that was close. And that helped me narrow down the search terms because connectors apparently have names. I don't recall what these were called exactly, but they were vintage Amphenol connectors. And I found sellers that had similar styles to this. They made them in different configurations. These are all 6-pin connectors. There were like 2-pin connectors, 4-pin connectors, 5-pin connectors, 8-pin, you know, lots of different configurations. But I found a seller that was actually in Texas, and he had these shown, and with a little bit of reasonable deducing and laying out the pin layout, because the pins are not spaced evenly all the way around. That's done so you can't plug it in the wrong way. I found these, and they were reasonably priced. I got 2 complete sets, so you get the plug and the socket. I got 2 sets. This socket's already been used for something, and I think they were about $9.95 for 4 pieces, which is pretty fair. That's not bad. And the reason I need these for a couple things. Mostly what I needed them for was I need to make up a test cable to plug in the remote station that the customer that owns the RCM4 sent along with the master. And here's that test speaker. This is a remote station from one of the rooms in his house. And on the back of it, it's got the same socket connection as on the master station. And again, the way this was made is the cabling from Rittenhouse came pre-made, had these connectors connected on the ends of the cables already, and then all you had to do was plug them in like that. So I could have made up, sort of pieced together a cable and connected it to the back ends of the socket and do all of that, but that wouldn't have been as good. And since I was able to find these, I'm more than willing to invest a few bucks. In fact, I'm going to buy more of these. I'm going to buy probably 5 more sets, because this is the kind of thing that when you see it, that's a good time to buy it, because I may need them in the future. And to show you where the 4th piece went, it's right here. So this is a socket, one of the ones that I bought from the guy in Texas, and I so far have made this up to enable me to plug in the little short cable on the back of the master station, the one with the plug on it. The blue and the yellow wires, these are the power wires, so then I can hook it up to my bench AC power supply and just plug the master into this, and that makes it easy. The other connections on here are for a door speaker and a doorbell push button, because the door chime is built into the intercom and the door speaker is the door speaker connection. Ultimately, I'm going to add to this and add connections for a door station so I can plug it into my door station that's over there on the end of the workbench, and a push button to make the doorbell ring. And this just makes everything so much easier when you're working on stuff, because you have a proper test setup. Proper test setup will include, we need to make up a cable that goes between this remote station and the RCM master station, and that's what I'm going to do today. So I made this diagram. This is a diagram of the layout of the socket in the remote station, and also it would be in the master station. This shows the layout of the pins. On the plug-in, you have one in the center, you have one on either side directly across from the center. You have these two at the top that are kind of offset, and here one, the last one is here down at the bottom right below the center pin. And if you look on the plugs on these, they're actually numbered. So it starts here, it's 1, 2, 3, 4, 5, and in the center is 6. Now the center pin, it doesn't actually say 6 molded into the plastic next to it, but it's obviously the 6th one. Or in the way some things work is you have 1, 2, 3, 4, 5 around the outer edge of the plug, and then of course 6 is in the middle. And looking at the back of the socket on the remote station, these are the colors of wires that are connected to them. So number 1 is white, number 2 is orange, number 3 is blue, number 4 is yellow, number 5 is green, and the center pin technically is black, but in my test cable, number 6 is going to be brown, because I have a lot of colored wire, including white, blue, green, yellow, orange. I do have black, but black gets used for lots of things, and I have less black than I have all these other colors. It's reasonable to use brown. I'm just conserving black wire. That's what I'm doing, and it doesn't really make any difference. It would be great if they were all exactly the Rittenhouse colors, but in this case, we're going to be practical and we're going to use brown. One of the things I don't know, so here's our wire. It's a big mess right now, isn't it? Yeah. So one of the things I don't know, and these are all 8 feet long, because it's nice to have an 8-foot test set up so I can plug it into the master station on the back of it here on the workbench, and then it can run over there to the roll-around cart where the remote speaker will be. You need some decent separation, because for intercom functions, if it's too close, you'll get feedback and it will howl. And any of you who have watched my videos know about the howling intercoms, because that's one of the things that happens. And also the difference between making it 6 feet and 8 feet is a couple more feet of wire, and what do I care? Now, the thing I don't know about the Rittenhouse cable is it individual wires made up into a cable, or are there twisted pairs within the cable? Twisted pairs would be like they deliberately took 2 colors like orange and brown and twisted them together with some predetermined number of twists per inch. I don't know that, and I don't really have any way to find that out. You would have to have a piece of original cable to know that, and I don't have that. So what I'm going to do is I'm going to take these and I'm going to make them up as if they were just basically a standard sort of 6-conductor cable. And a standard 6-conductor cable, if you went down to the low voltage supplier and bought a box of 6-conductor cable that was just sort of your general purpose sort of cable, what you would have would be 6 individual wires inside a jacket of some kind that had what I often refer to as a casual twist, which means that when it was made, they took the 6 wires and they twisted them together to some small degree so that when it went through the machine to put the jacket on the outside of it, they didn't get all tangled up and make a mess. This, the power cable I made up, which has yellow and blue wires, not for any particular reason, just because I had already twisted these wires for something else in the past. This would be a twisted pair, where it's twisted tight and not any specific number of twists per inch. That's just the way I made it up. As it was from a video I think I made, I don't remember, but it worked out well for this. See, when you twist the wires together, it keeps it more organized instead of having a bunch of loose wires flapping around, which nobody likes. So we're going to do this the way we normally do it. We're going to take our cordless drill. We're going to put the 6 wires in the chuck, tighten it down just a little, and we're going to spin it like that. That's what I would consider to be a casual twist. It's not twisted, they're not pairs, it's just twisted together. And all I'm going to do is I'm going to keep spinning the drill and keep sliding my left hand further and further down the bunch of wires until, of course, I can't reach anymore. And that's always exciting. So let me detangle a little bit and see if we can get the last little bit here. All right. Okay, that's as far as I can reach. So now what we'll do is we'll take this out. See, we've got our casual twist here, but we got this rat's nest at the end, and we don't like the rat's nest thing at all. So we'll straighten this out some. And this is not super critical, but one of the things is if you're building a test setup for something, let's do a good job. In fact, what we're going to do here real quick first is we're going to cut the ends off just a little bit, even them up, because that way they'll go in the chuck better. And I think, whoops. And I believe if we do this, there you go. If you're going to build a test setup, let's build it really well. Let's do it once, do it properly, and that way we can use it for years and years and years, and we don't have to horse around with it. Now, we don't want these, they don't need to be super tight, but now we have sort of an organized, casual bundle of wires. The next thing we need to do is we need to do something. We can't just leave them like this, because as you can see here, they will want to untwist, and as you move it around on the workbench and things, it will become loose and it'll fall on the floor and do all those things. So what we're going to do is we're going to use some heat shrink tubing, and we're going to feed the casually twisted cable, because now this is a cable now. This is not just individual wires. We've twisted the wires into a cable and feeding them through. Sometimes is easy and sometimes is more tricky. And since it's not really very exciting, I will pause and come back. So I cut 9 pieces of heat shrink tubing and slid them over the cable. I did leave sections here that are open because that way I can fold this up and put it in a work tub with the test as a test setup for Rittenhouse intercoms. And now what I'm going to do is I'm going to heat the heat shrink tubing to make it squeeze down on the wires. That way it doesn't slide around. A lot of heat shrink tubing that you can buy nowadays has a very sort of light adhesive inside of it that I suppose is probably heat activated, and that helps it stay in place. Sometimes if you get regular heat shrink tubing, especially if the pieces are short, over time they'll slide around on the wires. Of course, it also depends on what kind of wires you use. If you buy wire that has silicone insulation, nothing's really going to stick to it, and they tend to slide around a lot. I have other test setups that I made like that. So I'm going to go ahead and do all of this, and then the next step is going to be putting the connectors on the ends of the wires. So I'll be back in a couple minutes. Alright, the heat shrink tubing is done, and now it's time to put the connector on the ends of the wire. So let's move this out of the way a little bit. So what we're going to do is, first we're going to start off by taking the end of the twisted wires and we're going to cut them all off so they're all exactly the same length, because making them uniform is better. And now we're going to untwist some of them so we have enough to work with. And the way this works is, on the top of the plug are the 6 holes, and the wires go through the holes and then down inside the pins. The pins are hollow, and there's actually a little opening at the bottom. In fact, you can see it if I get, let's see, where is it? This will work. Oh, this is better. If I get this little metal rod, you can see that it slides down the hole. And that's where it's going to get soldered. So what you want to do is, you have to strip the insulation off, but you want to make them all the same length, and that length should be the length of the hollow metal pin. So we'll take one of these, we'll start with the white one, and we'll just hold it up like this. This is the easiest way to do it. We'll hold it up and we'll mark it with the red Sharpie, and then we will mark all of the other ones so they'll all be exactly the same, and then we'll strip them like this. Now I have some experience with this in that on NuTone systems do not use connectors like this. However, the model 256162s use a similar sort of plug arrangement with the little hollow metal pins for the antenna connection and for the multi-pin connection, which ties the master station to the terminal strip, which is where all the wires from all the remote speakers and power and antenna and everything are connected. Now I don't know whether those are Amphenol or not, but similar style, same sort of pin idea with the hollow tubes, and you solder it in and do all that sort of stuff. So I have fixed many of those where the wires break off, and this is very similar. So now I've stripped them, and I did twist all of the conductors, all the little wires. This is stranded wire. I twisted them all together to make them nice and neat and organized. And what I'm going to do is I'm going to lightly tin each one. Tinning is just heating it up and adding a little bit of solder, basically soldering the strands together. And the reason you want to do that is Since we have to get solder to flow down inside the little hollow pin tubes, if it already has some solder on the wire, that will help transfer the heat from the soldering iron better and make the solder flow better, and it all works out better. We know from our diagram that the center pin is brown, black originally, but brown in this particular case. And all we're going to do is we're going to slide the wire in. I'm going to let it poke out of the hole in the end of the tube just a little bit. And the trickiest part on this is you have to find some way to kind of hold this down so when you solder it, it stays in place. And all you do is you take your soldering iron. I'm using the largest, heaviest tip that I have. It has the most thermal mass, which means that it holds the heat better and it won't cool down as fast, because we are heating up a fair amount. We have the hollow metal tube and the wire, and we have to heat up. The tube is about a little more than a ½ inch long probably. So you've got to heat it up for a couple seconds, and then you take the solder and you stuff it down inside the tube and let it sort of sink. Now, one of the things about soldering something like this is the solder will flow towards the heat. That's the way it works. That's like when you solder copper plumbing pipe, you hold the torch down from the joint, and that way the solder flows through the joint to seal it and then towards the heat source. That's the way it works. So it's kind of the same with this. If you tend to get a little bit of a blob on the outside of the pin, which you don't want because these are a fairly tight fit, you just sort of take your soldering iron and knock it off and it'll be fine. And then we're going to clip off the little bit of wire that sticks through the end of the tube because we want it to be nice and neat. So that was number 6. Now we're going to do number 3, and you need to make sure you look at the numbers on the body of the plug to make sure you get the right color in the right slot. And we'll put this one in. And this is why, I tell people this for a lot of different things, this is why having a diagram is a good idea. You can refer back to the diagram. It's not like it's the end of the world if you get 2 of them mixed up, but if you think about it, if you get off kilter with the order of wires, you might find at the end that you got them all one slot off. And the other thing which you have to think about also is, since we have to put connectors on both ends, the order of wires, which color into which pin number, it has to be the same at both ends. You can't switch them around because then you have misconnections. They're not connected correctly. So you have to do it properly. So number 4 is yellow. One of the things I like about these connectors are they're very old school. They're big, they're heavy, they're kind of bulky, which is good because that means they're sturdy. They also get really hot when you solder them. So number 5 is green. And having dealt with these in the past, it's easy enough if you have to fix this or change it to do that, because all you have to do is heat up the tube with your soldering iron and pull the wire out. And then you can cut it, trim it, put it back together. It's easy. And easy is good. Now I assume that when these were manufactured at the Rittenhouse company or wherever it was that they were done, they probably had some kind of, now on number 1 is white, they probably had some sort of semi-automated soldering jig set up. I doubt somebody sat there one by one soldering wires into little hollow metal pins, although you never know, but I doubt it. It was the mid-1960s or early 1960s. It wasn't in the Stone Age. All right, there's that one. And the last one is number 2, and number 2, according to our diagram, is orange. We'll put that one in like that. And we'll make sure we don't have any solder blobs, but I think I was pretty careful. I think we're pretty good. So once you've done that and they're all soldered, then all you have to do to clean it up a little bit is just twist it back together. I suppose it makes good sense to sort of tug on it, make sure all the wires are actually in, but I'm pretty sure they are. There's our wiring harness. I already did the first end. That one's all done. So now we have a reproduction or a reproduced Rittenhouse intercom cable with connectors at both ends. So now we could take the customer's remote station and we can take our connector and plug it in, and then we can take the other end of the cable and plug it into the RCM4 master station, and they'll be connected together and we can test it. So that'll be happening soon. I've made good progress on the master station. It actually does play now. It's been interesting and moderately exciting to work on, but that's for another video. We'll get back to it. I'm waiting for one more. There's been a couple parts orders for it because it uses a lot of old school parts, not things that we typically have around here, and I've had to order it. And then sometimes what happens when you work on things for the first time or things you don't work on a very regular basis, as you work on it and you repair things, then you find more things wrong with it. The initial problem with it was dead. So then it became alive, and then we found more things wrong. So I had to order some parts for it. When those parts came in, then I fixed more of it, and then I found other things that were wrong with it, and then that required more parts yet again. But fortunately, the supplier for it is pretty speedy. Like, I ordered some things this morning and they were shipped out within an hour of me ordering them, which is really great. That's the end of this part of the repair of the customer's RCM4 master station. Audio cable all made up, or intercom cable all made up. If I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.